Scientific notation. Scientific notation is like an abbreviation to write very long numbers and really small numbers in a small, simple way. It is important because in science we can take a lot of time dealing with such numbers. Just imagine multiply them, and even if we use a calculator, we are going to be having trouble in in typing all those zeros. So here is when scientific notation help us to deal with numbers that are really big or small. We can get rid of that many zeros and write them in a very simple way. So firstly, I'm going to show you this number. It's a very long number, and then we are going to see how we can write this number that is written in decimal notation, and we are going to write it in scientific notation. First, we're going to figure it out, where will the decimal place be? So we know that the decimal point is right here, and we are going to begin from there. So we are going to move this decimal, and we are going to count the numbers of place values, the spots that we are going to be moving to the left. So let's begin. 1, 2, 3, 4, 5, 6, 7, 8, and 9. We are going to be here in the very last digit on the left, and we are going to put the decimal right here to the right of the number. So we move the decimal in that direction, and we move it 9 places. Remember, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we are going to write the same number. We are going to use the new decimal, and we are going to get rid of the zeros. And then I'm going to write down 10 raised to the 9 power, which is this one, the same number. The same, the little number here is the exponent, and it's the same number of the spots, the places that we move to the, in this case, to the left. So we have our new number, same number. This is in decimal notation, and this is in scientific notation. So now we can try another example, and we can try a long number 2. So let's see if we can write down, for example, 5,860,000, and we are going to make it to scientific notation. So now we do the same thing. We find the decimal right here and begin counting to the left. 1, 2, 3, 4, 5, 6, and we remember we are going to leave the last digit that is not a 0, and then we write down the decimal, the new decimal, to the right of that number. So we write it right here, 5.86. Get rid of the zeros. We went that direction, and we move the decimal 1, 2, 3, 4, 5, 6. So that's going to be the exponent for our 10 right here. So we have this number, 5,060,000, is the same as 5.86 times 10 to the 6th power. So now we are going to see something different. So let's see another one, but we are going to go in a different direction. Let me show you which number I'm going to show you. So let's say that we have this number. This is a number that is really long number, but it's in the opposite direction. It's a very, very small quantity and very small amount. So here we are going to do the same thing, but we now know that the decimal is right here. It's really clear. So we are going to begin counting to the right, but this time we are going to find our first digit that is a non-zero, and then next to that number we are going to write down our new decimal. So let's begin. 1, 2, 3, 4, 5. So right here we write down our new decimal, and then we know that we went that way 5 places, right? So we have 2.31. We get rid of all these zeros, times 10 to the 5, the fifth. But in this case, we are going to use negative sign because this number is really, really small. Okay? So it's different. Remember, we use a positive number here. And now we are using a negative exponent. Okay? A negative power. So now we are going to see another example. So let's say 0.1, 0, 0, 0. So I'm going to write down a lot of zeros. And then I'm going to end with 1, 7. Okay? So let's do this one. So we know that we are going to find our decimal. Right here is the decimal. And then from here, we're going to begin counting to the right. 1, 2, 3, 4, 5, 6, 7. So here, we are going to begin. We found our first non-zero digit, and then we write down our new decimal point. So here, we are going to write down 1.7, and then let's count again because 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be times 10 to the minus 8. And this is our scientific notation, our number in scientific notation. So the difference is really, really easy to see what is the deal with these numbers. Let me show you something here. So here, let me show you. So when we have the decimal, we always find the decimal point first. And if we have a number that is a big, long number in this direction, we are going to move our decimal to the left. And that exponent is going to be a positive exponent. Like in the first example that we just did. Remember? So it was 10 to the 9. We went from here to here. And then our scientific notation number is right here. And then the opposite happens with our number that is really, really small. Did you see this one? So when the decimal initially when we just saw the number, the decimal was right here. So we need to move to the right, but our exponent is going to be negative. So it's really easy. But now let's just really quick try the opposite. What about when we have the opposite? We have a number that is written in a scientific notation, and we wanted to have it in the in decimal notation. So the